is now with our data loaded into the data model, relationships created between tables, a slicer for the month selection, and some measures created, the total actuals and total budget. Dragging the total actuals measure onto the canvas shows the sum of actuals, which actually correlates to our net profit for that month. So there was $6 million net profit for May 2022. Let's look at some other tables in here. We navigate to the table view, click on the chart of accounts table, and can see that this shows our account hierarchy. We have an account key and categories for each account. For example, salaries has a header assignment of operating expenses, a subheader of labor expenses, and a subheader 2 of salaries. This account hierarchy will form the foundation of our income statement in Power BI. Let's now start to build out the income statement using the table or matrix visual. We've selected here the table visual and dragged the header assignment, subheader, and subheader 2 columns into it. And converted it into a matrix so that we can get the accounts hierarchy on rows and the total actuals as values, like we would in a pivot table. This starts to look like what we want on the income statement, but it isn't quite right. The headings are in the wrong order, and we don't have any subtotals such as gross profit. And unlike in Excel, we can't just insert rows into this table matrix and add a formula. Note that there are custom visuals in Power BI, such as Zebra BI tables and Info River Matrix, which allow you to do this. But here, we just want to use the native visuals which are built into Power BI. And the way that we can achieve this is to have a helper table, which we can define in Excel or in Power BI using Enter Data. This defines the layout that we want for the income statement. This is an example of such a table in Excel. It defines the rows of the income statement that we want in the required order. We start with revenue, followed by net sales, cost of sales, gross profit, and then gross margin. We need some additional metadata to help define the layout too. There is a column here called calc type, which tells us how this row on the income statement should be calculated. Calc type 1 means that this income statement row relates directly to a chart of accounts heading. So revenue, cost of sales, and operating expenses, for example, were all examples of values in the header assignment column in the chart of accounts. Calculating these rows is actually very straightforward. If we create a relationship between this table and our charts of accounts, the actuals measure that we already have will just work for these rows. The rows marked as calc type 2 are all subtotals, i.e. the sum of all the calc type 1 rows above it. So gross profit is the sum of revenue and cost of sales, and operating profit is the sum of revenue, cost of sales, and operating expenses. Note that this is because our actuals measure already calculates our credits as positive and debits as negative, so our operating expenses is a negative value. Because this follows a standard pattern, we can use this pattern in our formula to calculate the same way for every calc type 2 row. And lastly, calc type 3 is just a custom calculation. We define a separate measure, a separate formula for each calc type 3. So we have a measure for gross margin and a measure for net income margin named exactly like that. And then when it comes to calculating a calc type 3 row, we just have a single dynamic measure that looks at the name of the row and returns the corresponding measure value. We'll see all this with an example in a couple of minutes, so don't worry if you didn't grasp all of that just for this explanation. But just to finish off with this helper table, our last column is type, whether we want to show this as a currency value or a percentage. Obviously, for our margins are the ones that we show as percentages. This table in Excel was actually one of the worksheets in the reference data file that was contained in the data folder, so we just brought it into our data model just like all the other tables. We actually didn't need to apply any transformation logic to it. Once we've done that, and now in our data model, we navigate to the data model view, so the third view in the view pane on the left, and we create a relationship to the chart of accounts. We can do this just by dragging the header field from the income statement rows table, our helper table, to the header assignment field of the chart of accounts. This creates a relationship between these two columns. The relationship type is one to many, which is what we would expect. Each row only occurs once in the layout table, but all the calc type 1 rows map to multiple accounts in the chart of accounts. And then we set the relationship to both here, which helps with not displaying blank rows in the income statement. We click OK. Now, back in our report view, let's replace the header assignment field from chart of accounts with a header field from the income statement rows on the income statement matrix. And we can now sort the field by the sort order that we have in the layout table. To do this, click on the header field from the income statement rows table in the field list, click on the contextual column tools menu in the ribbon, select sort by column, and choose the order column. Now the matrix is showing the rows in the correct order, but it is currently only showing the actuals values where they relate to a chart of account header, i.e. just the calc type 1 rows. All the other rows are currently evaluated for blank. For example, for gross profit, it's filtering down the chart of accounts table to where the header assignment is gross profit, and then passing the filter table through to actuals. Of course, there are no accounts in the chart of accounts with a header of gross profit, so it's passing through a blank table to the actuals table, and then into the evaluation of the actuals measure, which is why it returns blank. So we need to define the calculations needed for calc type 2 and calc type 3 rows, and then dynamically pick the right calculation against each row, depending on its type. We start with creating a running total measure, or cumulative total measure, for calc type 2. This uses a standard cumulative total pattern against the income statement rows table. We can see the formula here, which is calculating the total actuals measure for all rows of the income statement rows table where the order is less than the current sort order, i.e. the sort order of the row being that the measure has been evaluated for. And for our custom calculation, calc type 3, we need to create a chain of measures for our gross and net margin calculations. So we start with revenue. The revenue calculation is just calculating total actuals in the context, i.e. with a filter condition using calculate, where the chart of accounts header assignment is revenue. And then the gross margin calculation is a calculation of revenue plus cost of sales divided by revenue. And net margin is net profit, which is actually just total actuals without any filters applied, divided by revenue. We then create our custom calculation measure for calc type 3, which is a dynamic measure using the switch function to look at the name of the layout table row and return the corresponding measure. Finally, we have the actuals measure that we will use on the income statement. This is a dynamic measure, again, using switch. It looks at the calc type that is selected, i.e. is in scope for the income statement row that the measure has been evaluated for, and returns the corresponding measure for that calc type. Now, when we bring this measure into the matrix, we can see it's evaluated for all rows of the income statement, unlike the original actuals measure. The only issue now is the formatting. We could format it as a currency, in dollars, for example, like we've done for the original actuals measure, but then our gross margin and net margin would show us $1 rather than 67% or 0.67. And we actually want to show those values as a percentage. And we marked it as such in the layout table. Against gross margin and net margin, the type column had percentage in there. Traditionally, every measure in Power BI had one format. It could either be a currency or a percentage, for example, but not both. But a couple of years ago, Microsoft introduced dynamic format strings, which means that the same measure could take on different formats depending on conditions you specify in logic in adapt formula. This is the measure that we use as our dynamic format string. The format string returned depends on both the type of the format specified in the income statement row table against that row, and also whether there is a single organization in scope. So the first check is whether the format specified in the income statement rows layout table is currency or percentage. If it's percentage, the format string for percentage is just returned. If it's currency, the next check is whether there's a single organization in scope. If there is, it will actually return the currency string that was in the organizations table for that organization. We can actually apply the same logic for our actuals measure, and therefore we can show local currency amounts formatted correctly with the local format currency string if the user has selected to view the data just for a single organization. Otherwise, if there are multiple organizations with multiple currencies in scope, then it will show reporting currency amounts formatted in USD income statement measure to be dynamic, using this format string measure as the dynamic expression.